In this video, we are going to talk about the equation of a tangent at a point to a parabola, right? Let's consider the parabola, the equation of the parabola, y squared equal to 4ax. This is the equation of a parabola that's opposed to the right. That is, the x-axis is the axis of symmetry. So, let's say a point x1, y1 lie on this parabola. Let's say this point is on this parabola. So we can say that this point satisfies the equation y1 squared equal to 4ax1. Yes, the point lie on the parabola, so it satisfies this particular equation. Now, a tangent is a straight line, right? It's a straight line. So we can use the equation of a straight line to determine the equation of a tangent. Using the gradient and 1 point form, there are different forms of the equation of a straight line. So the gradient and 1 point form, which is y minus y1, okay, equal to mx minus x1. This is what we are going to use to determine the equation of the tangent to this parabola at this particular point. x1 is x1, y1 is y1. What is m? M is gradient. Okay. Now, listen. The tangent is at a point to this parabola. So the principle is that the gradient of a curve, parabola is a curve. The gradient of a curve at a particular point is equal to the gradient of a tangent to the curve at that same point. So the gradient of the parabola at this point is equal to the gradient of the tangent at this same point, since the tangent is to the parabola at this particular point. So I want to determine the gradient of this parabola, all right, and set that equal to the gradient of the tangent. Since it is a curve, dy dx gives gradient, all right? Dy dx will give us the gradient. In calculus, gradient is rate of change of y with respect to x, which is dy dx. So I want to differentiate this equation now with respect to x. y1 squared equal to 4ax1. So let's differentiate this with respect to x. If I differentiate y1 squared with respect to x, that will be 2y1 dy1 ds1. Okay, I'm differentiating this with respect to x1 anyways, alright? If I differentiate this with respect to x1, it is 4a. So from here, dy1 dx1 is equal to 4a all over 2y1, right? So 2 cancel 4, that's 2. We are having 2a all over what? y1. That is the gradient of the parabola, all right? So I want to place this here. Y minus y1 is equal to 2a upon y1, all right, all into x minus x1. To eliminate the fraction, let's cross multiply. Y1 multiplies everything here. That's y into y1 minus y1 squared equal to 2a into x minus x1. Okay, let me expand this bracket. 2ax minus 2ax1. And here we are having y into y1, alright, minus y1 squared. Now, remember, what is y1 squared? 4ax1, right? So, y into y1 minus 4ax1 equal to 2ax minus 2ax1. So if this crosses, we have y times y1 equal to 2ax minus 2ax1 plus 4ax1. So y times y1 is 2ax minus 2ax1 plus this is plus 2ax1. So finally, y times y1, if we factor out 2a, we'll be having x plus what? x1. This gives the equation of a tangent to a parabola at a particular point. The question says, the first question, Find the equation of the tangent to the parabola 4y squared equal to 64x at the point 3, 5. Solution. The parabola has the equation 4y squared equal to 64x. So, dividing both sides by 4, y squared will be equal to 64x all over 4. Y squared is equal to 16x. Okay, so this is the standard form of the equation of the what? Parabola. Now, the equation of tangent to a parabola at a point is y times y1 is equal to 2a into x plus x1. Okay, x1 is 3, y1 is 5. What is a? That's the next question. The equation of the parabola that we saw earlier is y squared equal to 4ax, right? Y squared equal to 4ax. If I compare this equation now with this one, I can see that 4a is equal to 16. So 4a is equal to 16. If I divide both sides by 4, a is equal to 4. That's what it means. So a is 4. That means we have y times, what's y1? 5. 2 into 4, x plus x1 is 3. So 5y is equal to 8 into x plus 3. Alright? So this is 5y equal to 8x plus 24. So I can leave it like this. Or if I divide both sides by 5, y will be equal to 8 all over 5 of x plus 24 all over 5. So this is the equation of the tangent to the parabola that has this equation at this point. So what is the equation of the tangent to the parabola that has this equation? 2y squared equal to 16x at this point. Very easy to get. 2y squared equal to 16x. If you divide both sides by 2, it means that y squared is equal to 8x. So, if we compare this with the general equation that says y squared equal to 4ax, it is obvious that a is equal to 2, because it is 4 times 2 that will give us 8. So, a is equal to 2. So, the equation of the tangent to the parabola at this point is this. We have y into y1. What's y1? 4. Equal to 2a, and a is 2. All into x plus x1. x1 is 4. So 4y is equal to 4 into x plus 4. Right? 4 cancel 4. So y is equal to x plus 4. And this gives the equation of the tangent to the parabola at this point. Alright? This is how to determine the equation of the tangent to the parabola at a particular point. I hope you like the video. Keep supporting by subscribing to this channel. Like and share the video to your friends and to your classmates.